I don't know if their internet connection's very good out there.
Yeah, I think he's on his phone and it's a little bit dodgy.
Well, did you get a chance to go to Ross World yesterday?
I did not. Did you?
Yeah,
What did you learn?
a lot of stuff going on, a lot of cool things.
Yeah, I bet. What do you remember that was impressive?
Mm, I'm just surprised to how much work's being done. And then also, I did go to that drone. There's a lot of different series, so they branched out, and that got a little confusing. So I got to go back and watch the video tracks of the other ones. But there's a lot of good information. I looked at getting like maybe a small drone. We need to add drones to the agriculture project.
So many things to do.
Yep.
Because, and what's the for um, analysis or delivery or what in particular about drones was appealing?
I think scouting.
For plant health, insects.
Yeah, so I spend a lot of time scouting, just walking around, driving around, and if I've got a bad weed patch or a bad spot or damaged soil or whatever, it'd be nice to be able to send out a little drone to take pictures of that. You know, as I'm treating the area, how is it progressing? How are the weeds growing? If I do some sort of intervention, is it working? Is it not working? How is it spreading? You know, how is the disease spreading? How are the weeds moving?
And
And
doing
then
it as
so like
opposed to driving
yeah,
it on an ATV.
yeah, so you just fly out there, take pictures of it, and then if it gets to a certain point, like if I look at the pictures and say that's it's getting out of control, then I can send in a ground robot to do some intervention.
Jonathan, did you happen to watch any of the Rosscon stuff?
Was this Roscon?
Was it Rosscon or Ross World?
Ross
No,
World.
I haven't, but I'd like to. Is there a link on the Slack?
The videos will be posted here shortly, so once the videos get released, they'll we can post that again.
Matt, were you
Bigfoot.
saying you want a quadcopter?
Yeah. Yep.
Yeah, those big Chinese spraying quadcopters look really neat.
They do look neat. I don't know if we can use those in the US yet, but those look really cool. Tons of uses for those. And the drones
Is
can
there
go
a problem
around.
with the?
I don't think they can sell them in the US yet. Last time I looked, but getting over rough terrain and then having the ability to spray, I think is really cool.
Is the problem because they use a different satellite network or something? Like there's what is there? There's GONLAS and
I don't know. There's some strange rules around drones and commercial farming. So, like, yeah, you have if you're a commercial grower, then you have to have like an FCC license and a pilot license to be able to fly those, and then you're restricted on different activities. So, but
yeah.
I've been out of that world for a number of years, so I was just trying to learn a little bit more about where they are and what's the technology like, and what are some of the restrictions.
Yeah, what was it they were? You suggested them for Al's problem with some kind of bushes in his pasture. That were you trying to spray them with salt water or something like that, Al?
Well, I think people have mentioned multiple kinds of protocols. The problem statement is in regenerative farming, the fields are, encouraged to grow, and invasive species are coming in based on deer, you know, coming across the field and leaving droppings, and so now I've got invasive species trees coming up, and they've got to be whatever the right verb is, gotten out of there. So first identifying, and then spraying, and then I'm told I need this particular species. I'm told I need to cut and remove and burn is the proper protocol to make sure I don't leave anything behind and spread their seeds. Because I'm told if I go in there and cut them, I'll just be spreading their seeds all around.
Maybe you could modify the sprayer on one of those quadcopters to make it into a flamethrower. Tank of propane.
Yeah, I guess that would be, if not effective, certainly entertaining. Well, on my end, I have, let's see what I've been up to. I'm still trying to get, the real goal is to get a 2D NavGo to run, and to do that, I think I need to get a URDF file created and transforms organized for my robot. And so I've been on the path to, I'm just trying to share my screen here. These are just some notes, but so following the URDF tutorials, and then also Joseph Linton has a book, Learning ROS, and one of the, in his book, he's got a nice section around creating a URDF. So been spending time in that around creating the URDF. So, and then I did come to find out that SolidWorks has you can take a CAD model to a URDF. And then I also found out Fusion 360 has, maybe not as completely refined, but they also have some capability there. So yeah, there might be an opportunity to actually create a model and a proper 3D model, and move it into a URDF as well. So those would be the things that I've been working on most recently. Slow progress, but that's where my attention is. Anything, Jonathan, to share today? Your mate was on last week.
Oh yeah, I saw. I watched the video. Sorry I didn't make it. Yeah, I've got a tiny bit of progress. I can, I got some pictures. Wait, let me just, where have I put them? Can you see that?
The picture's not open up. There it is.
Yeah, so this is a little bracket with a rotary magnetic sensor, and this is a nut, which I put a little bit of electrical tape around that shaft and smushed that on there. And then there it is, bolted to, and you can see that nut just drops into the pot. Yeah, and that's the central steering
Awesome.
pivot. Yeah. I did that.
That's fantastic. Yeah, see how long it takes to do some of that mechanical stuff?
It took me a long time to get around. It didn't take me long to put it together once I actually got around to it. It was like 20 minutes, but took me a long time to get around to it.
And have you fed a
Yeah.
signal?
I've just
signal into anything yet?
No, I haven't actually. I put a potentiometer on it and twiddled it, and it seems to work. Yeah.
Because
I've
the next
also
thing
got
that'll be interesting is how much rotation you get, how big it's probably not proper, but I will say how many ticks do you get, how much resolution do you get in that signal.
Yeah. Oh yeah, I can't remember. I think I read it. I think it was like 1,000 per revolution.
And Jonathan,
increments, I guess 1,000 increments per revolution.
How do you know, like when you start that sensor up, it always starts at 0. So if your wheels are a little bit off, how do you know exactly where your wheels are?
You mean how will I guess to calibrate it, I can
Does it always start at 0?
You're going to always have to do that every time you start your robot.
No, I think once I've calibrated it once, so my idea to calibrate it is I can just measure from, I assume you're looking at my screen now.
Yep.
I can just measure from here to here with a steel ruler on both sides to make sure it's dead center, and then take a reading. I think that magnetic sensor will give the same output every time it starts up, so it won't need calibrating. It won't need recalibrating after every shutdown. I think once I can harken the values that it expects for straight, hard left and hard right, I believe.
Is it analog or digital?
I think it's an analog device.
Matt, why do you think it's going to be 0 every time, no matter what its position is?
It's a Hall effect sensor. I didn't know how it knew where it was. I didn't know. I was just asking. I haven't fired mine up yet, but If it always starts at 0, how do you know? Al, you're using some sort of a magnet sensor, Hall effect sensor. Does that always start at 0 when you power it up?
The magnetic sensor is based on the position of the magnet. So it, you know, it is always going to return what's the strength of the position of the magnet. So no matter if it loses, if the integrated chip loses power and then gets power again, the strength of the magnet is still basically the same. So it's going to give, you know, basically the same reading the next time the integrated chip reads the magnet strength. So I don't have to recalibrate it every startup.
Yeah,
My
that was
issue
my
was
understanding.
always, my issue was about getting multiple rotations from a full left to full right. That's why I had to have fancy code from Jeff to deal with, you know, multiple revolutions.
Yeah, that was my understanding as well. I think a Hall effect sensor is different, that it doesn't, like, whereas a rotary magnetic sensor has a permanent magnet in it, a Hall effect sensor, I think, uses electromagnetic fields, which is why it's not an absolute sensor, it's a sort of relative sensor. So yeah, this is where we really missed Jeff, I think, isn't it?
Yeah. I didn't know if it was, that's right. I didn't know if it was an absolute position sensor or a relative position sensor.
I'll check with my multimeter again, but I'm pretty sure it looked like an absolute position sensor.
No matter what, it's
That makes the
progress.
whole
I have
calibration.
a sensor stuck on there, and now you've got, next step is to plug a microcontroller on there to start getting readings.
Yeah.
You're well on your way.
Well, I might the North Wales lockdown has eased. We went into a fortnight of extreme COVID lockdown, which has just finished. So hopefully I can get Paddy and Lee round this weekend, and we can have a go at it.
No comment.
I've got I'm booked in for. Do you remember me talking about Land Workers Alliance? The Land Workers Alliance AGM is on the 5th of December. It's all an online Zoom event, and I'm facilitating a conversation. I wrote a 150-word blurb about it. I was just trying to look for it so I could anyway, essentially it says Land Workers Alliance should be collaborating with the open source community on robots, and yes, I don't know if either of you gentlemen would like to be a guest appearance.
Well, come on, man. Share your 150 words. Don't be stingy.
Okay,
Sure.
let me look for them.
I have to say, your education system is a heck of a lot better than ours. I'm sure your prose is very elegant.
Okay. Land workers and robots. Agricultural machinery and agrochemical manufacturers once coexisted. Now these multinational corporations are competing to own the data and intellectual property that will control the agricultural machinery and inputs of the future. The idea is that these emerging technologies will enable the further consolidation of corporate power over the agricultural industry. The open source project is a global grassroots collaboration to undermine corporate control of this emerging technology. As a market gardener working with the open source community to develop a DIY horticultural robot, I am proposing the Land Workers Alliance should seek to collaborate with this open source community. This session is an open discussion with two objectives. One, to develop a Land Workers Alliance campaign strategy on agricultural robotics, and two, to explore the potential for collaborative projects between land workers and the open source community. Yeah, so
That's fantastic.
yeah. Do you fancy coming along? And
Yes.
it'll be between 2 and 3 p.m.
Perfect.
On the 5th of December, so I can, yeah, I'll send you links.
Okay.
Yeah.
That'll be fun. It'll be fun to see the discussion and interest around that.
Yeah. I don't know how contentious it will be or not yet, but we'll find out. I expect that the people that are really ideologically opposed to any technology will not come to the session because they won't like the title. So I expect it'll be mostly full of people who are enthusiastic and want to sort of explore.
It's always good to have a contrarian, though. Helps keep some edges. Understand those concerns.
I would come
Expect
too
we'll
if
have
you
this
wanted a pudgy, bald, middle-aged guy, but Matt's gonna add more to the. He's gonna be easier on your camera than I would.
It'd be great to have you, Al. I'll send you both invitations. Yeah. I just did it's not really robot related, but I just got interviewed for a part-time work from home job with working for the Land Workers Alliance with
To do what?
with the most amazing job title. If I say, what do you do? And I can say, I'm a resilient local food systems project coordinator.
Fantastic.
Job title.
And put in the chat the URL for the group. I think that would be useful to look up their URL.
For what?
Do we still have you, Jonathan?
Sorry?
I was wondering if we still had you. I thought we had lost you.
I think you did for a while, yeah. What was the link you were hoping for?
The group that you're going to be the project coordinator for?
I'll just find it, yeah. Yeah, so Land Workers Alliance is the British wing of La Via Campesina. I was looking into it. La Via Campesina, it's like a labor union for peasant farmers, represents an estimated 200 million farmers worldwide.
It's awesome.
That's a lot of farmers.
Yeah.
It's really cool.
That's a lot of dirt under their fingernails.
The how's your mini John Deere coming on, Matt?
It's tore apart, but I'm trying to glue pieces together.
It tore itself apart?
No, I did.
All right.
I need to put some sensors inside of the model, so I tore the plastic housing apart and then working on where to feed the cables, you know.
Mhm.
I need to mount a camera on the roof, either the roof of the hood or the roof of the tractor. So I'm
That-
working on mechanical and then cabling, where to run cables.
Is that going to be your fancy double camera for fiducial navigation?
Yes, it'll be fiducial, single camera fiducial. It's a bit rough, but we'll see how well we can get it going. So before, what I did is I put a camera on the ceiling and then I put the fiducial marker on the robot, and then I drove the robot around and I could see where that is. But the other way, the correct way or normal way, is to put the fiducials on your ceiling and then have your camera facing up, and then you have to get three of the fiducials to triangulate your position. So I'm switching over to that mode.
Right.
There's an easy way and a hard way with robotics. If you do the easy way, you just keep it very simple and you follow the tutorial. But with everything with robotics, with fiducials alone, you could get a PhD on that work. Multiple people have gotten multiple PhDs on computer vision fiducials. So the kind of the trick with robotics, or what I found, is like you got to figure out what you want to get a PhD for. And most things, if you're spending more than a half an hour doing something, you're doing it wrong. You're just doing it wrong. Either you don't understand what you're doing and you need to go back and understand some definitions of things, or you need to find the right tutorial. So there's a difference between being an integrator and an inventor, if you want to call it that. You know, most of the work that we're doing with robotics has already been done. It was done in the 60s. So all of the things that we use, you know, if you use a PID algorithm, that PID algorithm has been used forever, since the 60s. If you use an EKF, that was developed. So if you find yourself taking a huge deep dive and pulling PhD papers and trying to understand what's going on, probably in the wrong space. Want to come back down to the very simple space and use the simple robotic techniques.
Yeah.
You can literally spend months and months and months doing something that takes a half an hour.
I'm
It's
hoping I
insane.
can just limit myself to mechanicals and horticulture and find colleagues to do the programming. And
Mechanical can get difficult also. You got to have a lot of experience and knowledge. I really like your robot design with the articulated in the middle. That's pretty popular. Um, but it seems like there's a big trend going electric instead of diesel or petro. Do you need that big diesel engine to run your implement power?
Uh, I haven't got a diesel engine.
Oh,
I'll show you my
are you running full battery?
yeah.
Wow. Okay. That's the latest and greatest. That's your big battery bank then on the front of your robot.
Yeah, I'll show you again. Um,
And then, like, how many kilowatt hours are you storing? I thought that was a gas tank, but that's hydraulic
that's
reservoir.
hydraulic oil.
Okay.
That there is the main electric motor, which came from an electric forklift truck.
Okay.
Um, yeah, and that's they are, I think, 110 amp hours and 12 volts each. So it's a 48 volt, 110 amp hour. So I guess that's about 5 kilowatt hours. Sorry. Um,
It's about
uh,
what's in a golf cart.
yeah. Um, I I don't think that would be enough. Basically, the one thing that I can't afford on this machine to be able to be able to do like an 8-hour workday is the battery. Um, uh,
Um, and then, so that those two cables coming down into that red shaft there, that goes down into a hydraulic motor down on your wheels.
yeah,
Four hydraulic motors on your wheels.
yeah. Wonder if there's no, I haven't got a picture of the hydraulic motors. Um, but yeah, you can see I've built that structure. So there's just a plate with a hydraulic motor in there. Um, uh,
So you
yeah,
have tons of power with that, right? I mean, those wheels don't get stuck, and you could climb a hill if you had traction.
yeah. Well, when I was driving it around, it got over a rock that was, I don't know, like
Wow.
2 foot high, something like that. One of the wheels, just the whole thing just will it'll yeah, it's got a lot of power.
Wow.
Um, it's fair. It's not that slow either. Um, but yeah, I would like to I'd like to improve my knowledge of hydraulic engineering. I'm not quite sure because mine, I probably explained it before that I've got two separate electric motors. So there's one hydraulic system which is just for the wheel drive, and a separate one which is for all the kind of control functions. Um, and the reason I did that, my concern was that uh, if you've got liters of hydraulic oil getting pumped to turn the wheels, and you want to make a very minor steering adjustment, that the whatever resistance happened to be on the wheels at the time, or the speed the vehicle was going, or anything like that, would affect whether or not, or how much pressure you got to the steering ram, and it might become quite unpredictable how it all got controlled. But when I look at lots and lots of other diesel hydraulic robots, like there was one that was posted on the I think you might have posted it, Matt, uh, on the Slack group, a fleet of
The Swarm
uh,
Farm. If you posted those, they're diesel electric
Yeah, diesel hydraulic.
hydraulic. Yep.
Yeah, so when I look at those machines, they're definitely getting all of their hydraulic pressure from a single power source, the diesel engine, but they're doing lots and lots of complicated control functions. Yeah, and I have tried to research control circuits, and I think it essentially works where you need a hydraulic pressure reservoir, so that's being topped up with hydraulic pressure, and basically it's a buffering to maintain a fairly consistent level of hydraulic pressure regardless of what's being taken off. And then a bunch of flow control valves for different circuits, so that yeah.
We ran into a problem with the proportional hydraulic valves. Are you running proportional hydraulic valves, or do you just adjust your electric motor? I was assuming your wheels are in series, and then you just adjust your electrical motor, hydraulic motor.
Yeah, well, the wheels are all in parallel.
Parallel.
Um, yeah, and that basically solves the differential problem. Um, uh, and but yeah, to change the speed of either the wheels or the speed at which an actuator moves, I've got speed controllers on the electric motors. Um, yeah, so that's why I can get away without having any proportional hydraulic valves. And that also saves on a bunch of other stuff. I mean, proportional hydraulic valves are expensive, but they also require much cleaner oil than the other kind. As in the way a proportional hydraulic valve works is that there's a spool in the middle which is pushed and pulled by electromagnets, by solenoids, and the engineering of the openings on that spool that let the oil through are yeah, they're quite precise. They've got loads of little grooves in and stuff like that in order to make it so that very small amounts of oil can flow, and those clog up a lot more easily. So you have to have much much higher filtration and cleaner oil if you're using proportional hydraulic valves. Yeah, yeah, I'd be really interested to see like hydraulic schematics for the swarm farm robots or something like that. Yeah, I've done a little bit of taking. We've got a mini digger. I did a little bit of taking that apart, but just to look at how it works and studied some of the hydraulic circuit diagrams. But there's something about, because it's manual, you know, you've got the two joysticks, and you can get what feels like proportional control because because it's quite manual, and you're manually actuating these valves, and you can do it just a little bit by feel. So they're not actually supposed to be proportional valves. Yeah, to get that kind of proportional, delicate control with electronics is much harder than with manual hydraulic systems, where you can rely on a person's feel to yeah, get
Feather.
subtle about it. Yeah, exactly. Yeah. Um, uh, yeah. Yeah. So it'd be really interesting to see um, more. Yeah, how those swarm farm robots solve a lot of their hydraulic issues. I expect they've got, you know, actual qualified hydraulic engineers that studied it, and so probably came up with much better design solutions than I did.
I'll show you one. This one we started with like a petrol, or it was just gas and electronics. So this is a homemade tractor, basically from pieces of metal. Bought the engine, but everything else is welded up and manufactured. This is with Open Source Ecology Group. But we didn't have proportional valves, and you can see, I was just trying to load here, but when he gives it the go, you know, it really takes off. It was really hard to even control with a human, like feathering, you had to like just be on the controls and they would just open and close. But when you open the valve, man, that machine really took off. This is about 7,000 pounds. I mean, it's all steel. Well, it's not.
Yeah,
playing.
wow.
I don't know what's wrong here.
You made those tracks from scratch as well?
Yeah. So it was a little tricky to try to like get that to drive right. Maybe there's a track picture here. That's the teeth. And so that's kind of the track pieces. Just cut the pieces off and then welded them all together.
Mm-hmm.
I was looking for a better picture of those, but it's a lot of work. This little piece here with a gear drive, that was a lot of work to cut that out. We cut that out and then you grind it and then weld it all up, made a few mistakes and had to cut it off and redo it. But it was a tremendous amount of work, like unbelievable. We just start out with metal and then you bend it and shape it and cut it and weld it and grind it.
Yeah.
Kind of the idea was, you know, you could put some simple material, you know, like a welder, grinders, pieces of material, all that into like a container and then ship that container on site. And then you could build these machines. It was a lot of fun.
What are, so when I try and research open source ecology, there seems to be a lot of material from quite a few years back, but nothing really recent. Is open source ecology still happening?
Yeah, it's still happening right now. There, before COVID, there was kind of a big push to build 3D printers. So sort of like workshops, and this would be like STEAM type camps and programs.
Yeah.
But the farm is still out there and they're still building equipment. I don't know when their last big equipment, they've done a few house builds, but last time it was just the 3D printers. Here's a little hydraulic motor that we use for the track and then the gear to turn the track. So there you go. That looked like fun.
Yeah, it looks like loads of fun. There's a trick with the mini digger. When people first get on it, they every time they move, they jerk and wobble all over the place. And the way to avoid that is you want to engage an actuator, then engage the next actuator before you release that actuator. So that, you know, if you imagine you've got 100% of the oil flow going to one actuator, then you want to split it 50-50 between one actuator and another actuator before you drop it. and then you move much more smoothly, and you don't jerk and wobble and get all of that impact. There's a kind of a technique
Okay.
thing of, so I can imagine, yeah. So where on that little machine you only had, um,
Track left, track right.
yeah, two actuators. So there wasn't really an option, but yeah, that's a kind of a manual trick for reducing that. I guess it means that you can decelerate with steps rather than you going from 100% to nothing and then nothing to 100%. Yeah. People don't like when I'm teaching people to drive the mini digger, and I tell them that okay, do the same thing, but keep at least one actuator engaged at all times. You have to one or two, but never none. And suddenly they panic, and the digger starts flying all over the place.
It's amazing. Those hydraulic motors, I was really surprised. I haven't worked a lot with hydraulic, and a couple things that surprised me is one, getting a pinhole in a hydraulic line. That can be dangerous. And then the other thing I thought was fascinating was how much force, how much power you can get out of a hydraulic motor. Even though it was going like we put like a solar panel on one and tried to see if we could move it through a solar panel, but the hydraulic motor will move slow, but it still has all the power. So it's pretty fascinating.
Yeah, they're good for slow moving applications. You can get really high gear ratios with fairly minimal losses. Like, so if you compare the efficiency of a mechanical drive chain to a hydraulic, mechanical transmission to hydraulic transmission, mechanical almost always wins. But it's much worse at high speeds. So if you're trying to like if you ever see a track front PTO, they're generally hydraulic motor driven, the front PTO, and when they're trying to do like 540 RPM or something like that, yeah, they become quite inefficient, just because you're moving so much fluid through all the pipes and everything, and then you have to have a hydraulic oil cooler, and yeah, you can get less than 50% efficiency on your transmission, but when they're going really slowly, you can very little oil has to move, so there's much less friction, and yeah, so they tend to be used where you want things to move really slowly with really high power, because you can convert the whatever it's 3000 RPM from your engine to 1 RPM with quite effectively. Yeah, I think that's one of the big strengths of hydraulics.
High power, slow moving.
Yeah, they do good at that. Yeah, I think it can be a lot easier to make DIY. I guess, yeah. Open Source Ecology found this as well, that you can do your own transmission systems, really quite off-the-shelf components. Whereas if you were trying to do that with gearboxes and stuff like that, you probably want like a machine station cabinet to be able to make all your sprockets and stuff like that.
Anything to share, Matt, before we close?
Oh,
Jonathan, anything else on your mind?
No, no, that's it.
Any more speeches you're writing? Grants? Submissions?
I got loads of those, but
How many people are you hoping to have on your talk?
I don't know. Every other AGM had for the Land Workers Alliance has been a physical event. So, but yeah, I mean, if they follow the trend of the physical AGMs, then it'll probably be sort of 20 people,
Cool.
somewhere around there.
UK, or I mean, given the footprint of your members outside of the UK as well?
No, Land Workers Alliance is UK only. Yeah, there's the British Peasant Farmers Labour Union.
Or you have to give Matt a speaking part so they can make comments about his accent.
Yeah.
Okay, guys. We'll
See you
have a
next
great
week.
weekend.
Have a good weekend.
Good luck with everything. We'll talk to you later.
Bye.